All right, let's get started. Okay, PS9 is coming due today or tomorrow at the late day. PS10 will be out tomorrow, and as I've told you, it's you'll be implementing a server to go with that works like my server. So first two assignments involving that, and then the PS11 you'll add a database to it. Any questions or problems about anything? Yes?
So when we have the board, does the first character that comes back from it as 0, 0 be the top left or the bottom left?
Okay, so he's saying you get the 16 characters for the board back. Where's the first character go? The top left or the bottom left? I think of it as the top left, but it honestly doesn't matter, because if you put it bottom left and then fill in the board from the bottom, you make the same words with it. So it's just a reflection. Yes?
With the cancel, the join game, I've been testing it on the REST, advanced REST client. I keep being a 403 forbidden. I make a user and then I do a join game like ready to cancel, all with the same user ID. And I still keep getting that 403.
And it's supposed to say, does 403 show up in the API as a?
I think you put that as. The 403 is like if it's like a null or like the game's not there.
So if the game ID is bad or the player ID is bad. Sometimes though, you get a 403 back from the server if the request was corrupted somehow. I've seen that happen.
Okay.
So it's not generated by my code, but before it gets to my code. So I haven't heard about an epidemic of this problem, so I think I'd be happy to look at your code. Any other questions? Yes?
We have this weird thing where if we cancel a join, it'll still join and then we'll be spectating two people play each other. And it only happens every like once in like blue moon, but do you have any idea what that could possibly be? What possibly could
That's going to be very specific to your code, so yeah, that would be kind of weird to have happen there. Any other questions? Okay, so a question on Piazza that's particularly important, that was asked twice yesterday, which is when you got to do something regularly, like if you got to keep pinging the server to see if the game has started, or you got to ping the server to get status updates, like every second, how to do that. And the best way is to use a timer. The problem is there are lots of timers. So what you want is the Windows Forms timer. And the advantage of the Windows Forms timer is the events are fired on the GUI event thread. So you don't have to worry about synchronization or cross-thread invokes.
Yeah, I think that's related to the problem we were having where when we would use we use systems.timers.timer, and when we try like changing our GUI board, it would feel like a cross-thread exception.
Okay, right. So if you use a different kind of timer, then those events are going to happen, and your handler is going to be running on a thread other than the GUI event thread. And as I've shown you in the past, from another thread, you cannot update the GUI unless you use the invoke method and pass in a delegate to do it. So avoid that and use the Windows Forms timer. Yeah.
Will it work fine if we create that timer in the controller instead of the GUI?
Yeah, either way should work. Yeah. Okay, any last questions? Okay. Oh yeah.
I have a question. So when you hit, so when you press cancel, a cancellation token should be fed to the server. However, like for some reason, we couldn't really figure that out. How does the cancellation token, when pressing cancel, affect the server, and how does that usually work?
So he's asking about the cancellation token. So when you make an HTTP post or whatever, you can pass in a cancellation token. That is nothing to the server.
Okay.
There's nothing you can do to cancel anything happening on the server. You can unjoin a pending game, that's about it. What that cancellation token does is it cancels the HTTP call. But the server does what the server does. So
Okay.
it doesn't see the cancellation token. Okay, anything else? Okay, so last time we talked about building a server. And I showed you how I built my to-do list server. And just to remind you, here is the to-do list server project. And it's got a lot of boilerplate, but the code that I wrote is here in to-do controller and also in these model classes. And the controller is the main thing here. And so the controller, I wrote the controller by putting 5 public methods in it, one for each endpoint in my API. And the important part, as far as the interface goes, are these 2 lines here. So we have the method called post-register that takes the parameter, and then we have that annotation up there that gives the URL that's used to invoke the endpoint. And ASP.NET looks at that and decides, okay, the URL is to-do/register user. It sees that the method starts with the word post, so it decides it's a post request that needs to be made at that URL. It sees that it takes a parameter, which is a user info parameter, and that's an object, so it's going to, by default, expect the object to be passed in the body of the request. And we saw how all that worked and how you can customize what ASP.NET does by putting in other annotations. But fundamentally, that's what you do, and then you just implement the method. Okay? And so that's what you'll be doing with the Boggle server you'll be doing next week, is you'll start by having some kind of a controller and start by just getting the plumbing right, making sure that the API that's generated by ASP.NET matches the one that you're supposed to be generating for your assignment. Then you can worry about implementing. And as far as implementing goes, I told you last time we'll use a poor man's database, which is essentially static variables to hold the state of the service, along with a synchronization variable that so each method is going to update, each endpoint method is going to update the state. Why is it important to have it be static in this poor man's database?
So that it has one instance of the dictionary for object.
Right, there needs to be one instance of each variable for the entire application. The subtle thing that you might not realize is that when, let's say, a post request comes in on this URL, what ASP.NET does is create a new to-do controller object. So it constructs an object and then invokes this method on it. So if you're using instance variables, every request is going to see, potentially, it may reuse, sometimes it can reuse these objects that it constructs. But it can construct a new object for each request, and each would see a new copy of the instance variables, and there'd be no state. So we create the static state, and we synchronize because why? Why is it important? You see what I'm doing here? Why is it important to wrap this in a lock? Because none of my code creates multiple tasks. Yep.
Because there'll probably be multiple people doing
Okay. There are going to be multiple users banging on the server at the same time. All of you are using my server at the same time. And the server itself is multi-threaded. It can deal with multiple requests at the same time. And so even though I'm not generating tasks, the server is, and so we need to synchronize between them. And I'm just taking the most pessimistic view possible, which is just to lock the whole thing up, do the method, and then unlock, which makes it sort of compromises the ability of the server to do parallel processing. So it reduces the throughput of the server. Now, you remember I discovered in class last time, oh, this got changed back. Anyway, I should change this again. I realized it was really bad to have this sleep for, oh, okay, that was a Boggle server. I have my Boggle server sleeping for 10 seconds inside of a lock like that, which meant when anyone passed in a username that starts with an @ sign, my service stalls for 10 seconds to let you test out cancellation, but everyone's GUI would freeze for 10 seconds if it was in the middle of making a method call. So I took that out of the lock. I put the lock around something else. So what I really should do is this. Just group it like that. And ultimately, we'll replace the poor man's database with a real database. And we'll start talking about databases today. Okay, so that's the high points of creating a service. So what? You're going to need some variables down here. What variables are you going to need for your database service? For your Boggle service? Yeah?
The score, the user score.
Well, you need the score, but remember there's multiple games going on. So you can't say the score.
Oh, sorry, how many they've won, how many games they've won.
Okay, you're saying how many moves they've won, but who is they?
The user. And
You keep using the singular.
Sorry.
You got to realize that the service is maintaining is keeping track of an arbitrary number of players and arbitrary number of games. So yeah.
So you have like some sort of dictionary with player IDs that links them to their nickname, dictionary for game IDs that links them to the players and the scores and the words and all that stuff, or database to store game and players.
Yeah.
On it.
So essentially, most of your representation can be in a pair of dictionaries. One that maps user IDs to information about the user, and one that maps game IDs to information about the game. There's sort of a special game. The pending game is sort of a one-off thing, so you might have to do something special to keep track of who belongs to a pending game. Now, you haven't thought about the server very deeply yet, but people always do this. They'll create their server, and they'll have a game, they have a dictionary that maps game IDs to game objects. Now, what would a game object contain? What do you have to keep track of for a particular game? Okay, the time left, well, let's think about that. So time left, the time limit, the words player 1 is played, the words player 2 is played, the scores, that sort of thing, yeah.
It needs to figure out all possible word combinations for that set of words, and so
Well,
that it can verify.
Yeah, you could figure out all possible word combinations in advance, but it's simpler just to, I'll be giving you a method where you can take a word that's been played and it'll tell you if it's a legal word. So that's not an issue. But I want to go back. It's tempting to say, you've got to report how much time is left whenever you're asked. So it's tempting to say that the game object ought to contain the time left, the number of seconds left in the game. Why is that practically impossible? Why is that a bad idea to keep track of the amount of time left? Yeah?
You'd have to alter data in the database for like every second for every game that's being
Right.
played.
Right, so say you've got 1,000 concurrent games going on, and you want your game to keep track of the amount of time left. Every second, you'd have to go update every single game and deduct 1 from the amount of time left. No, don't do that. What should you do instead? Because you've got to be able to tell the user how much time is left when they ask. So what do?
You store the start time and the end time.
Well, so you store the start time and the time limit. And then when someone asks, you just calculate it. So if you know the game started at this time, and the time limit is 90 seconds, you can figure out how many seconds have elapsed and just calculate the time each time you're asked. Don't try to store the time left. Just calculate it when you have to, because time's constantly changing. So you don't need a timer in your server. Okay, so you just figure out, it's just like implementing a class, except for odd reasons, these variables are static, and you implement the methods. But you're going to want to test your service. We're certainly going to test your service. So how do you do that? When you got a Boggle service up and running, how are you going to test it? Yeah.
Just play it.
You could play it. Certainly you could take your client and, instead of pointing it at my service, point it at your service and play it. When we grade your service, though, we won't do that. We won't be playing a bunch of games with it. What do we do? Yeah?
Just create a bunch of get, push, post, like just send a bunch of the responses and just make sure you're getting back
Okay.
what you expect.
So yeah, you can write unit tests. And the unit tests basically simulate what happens when someone interacts with your server, creates games and plays games. But with a unit test, you could test the ability of the server to support 10 games at the same time or whatever. So I'm going to show you 2 strategies for creating tests and tell you the pros and cons. So here let's see. So I have 2 test projects. This one here is called To-Do List Server Local Tests, and this one is called To-Do List Servers Remote Tests. So the local tests, when you create your service, it'll bring up a dialog that asks you, among other things, do you want to put a test project in? So tick that box to get a test project generated. And that's what I'm calling the local tests. And if I go look at the tests, you'll see what they look like. So these are just regular old unit tests. So here's, look at that one right there. Post-register test. So it's a test of the post-register method. So what it's doing is it's actually creating a to-do controller. You remember all the endpoints were defined in a class called to-do controller. And so we just create an object. It's supposed to take a user info object as a parameter. So I create a user info object with name and email. Then I call the post-register method. I get back a result. I assert that it's not null. I assert that it's 36 characters. Then I set the username to the empty string. I call it again, and I'm supposed to get an exception. So I verify down here that I get an exception and that the status code that's contained in the response is forbidden, which is what I'm expecting when you pass in an empty string in the user. So I'm just testing the controller, that post-register method directly. Right? This is just no different than any unit test you've written all semester. But it is in some sense, in some ways, inadequate. What is inadequate about this way of testing? What are we testing and what are we not testing when we do this sort of direct local test? What liabilities can you see? Yeah.
Well, is it, you're calling the method specifically instead of calling, like sending out the HTTP request?
Right. So when you test this way, you're not even running a server. There's no HTTP server running. You're just testing the endpoint methods that are used by the server. And that's important to do. It's important to test those methods and make sure they work properly. But there are mistakes you can make that won't be detected this way. Like if you mess up the URL that you put when you annotate your methods. Or if you do, problems that only come when the server is involved won't be detected this way. You'll just, you'll find some problems, you can't find them all. So a more robust test is to test the server. Test your code through the server instead of without involving the server. So I have a more extensive example to show how I do that. So this is to-do list remote tests. And I have 2 classes here. So let me show you this one here first. So this is just a regular old unit test that I created just like you create unit tests. And it makes use of this handy supporting code, which you're welcome to use. So I declare a struct called response that contains an HTTP status code and then some dynamic value that I call data. Then I have a REST client class. which provides a method called doMethodAsync. So the idea behind this method is you give it as parameters a string that says, okay, I want to do a get, a post, a put, or a delete. So that's what that parameter is. You give it the URL to use, and you give it an object to pass in the body of the request. And what this method does is it serializes the data, figures out what method you want me to use, and I either do a get async or a post async or a put async or a delete async, passing in the correct stuff. Then I wait till I get a response. If the response is successful, I deserialize the response body, and I return as a response object. I return a response object that contains the response code, the status code of the response, and the deserialized object response body. Otherwise, I just return a response that contains the status code. So what's this method for? This method is, we can use it to make any method call, and it packages up what comes back. It packages up the status code of the response and the object that came back in the body of the response and returns it to the user. So what's the point of this method? It doesn't do anything with the data. It doesn't interpret the data at all. Why would it be useful? Okay? So you want to write unit tests to see if stuff happens. Okay. How can you see using this method, this class, in your unit tests? Yeah?
It seems like it makes a real simple way to quickly send requests without having to do all that packaging and depackaging every time.
Right.
In your unit test.
Right. It just makes it gives you an easy way to invoke a REST endpoint and get a response back. And it might make writing your client easier if you use something like this. But anyway, it just lets you make an arbitrary call and it sends back what the response is. So that's that. Then we look at the actual unit tests, and let's see how they work. So first I create one of those REST client objects I just showed you, and you give it as a parameter of the constructor, you give it the base URL. So I expect the server to be running on port 44444, and every URL will start with that. So here's a method. So look at that. We create an expando object, we set the name and the email properties. Then we call the method doMethodAsync. We say, please do a post to the register user URL, pass that in the body, and give me back the response. So you get the response. The response will consist of the status code of the response and the body of the response. So I assert that the status code was okay. That's what I expect to have back. I assert that the length of the data that I get back, the data I get back, I'm expecting to get a string back in the body. That's just what that endpoint does. I assert that it's 37 characters long. So this is just that same test I showed you before, except made through the server instead of around the back of the server. I set the name to the empty string. I try again and make sure that what I get back is a forbidden status code, because you're forbidden to do this if the username is empty. So now when you run this test, it's going out on the net and finding the server. Well, in this case, it'll stay on the laptop, but it goes and finds the server, makes the call to the server. So you're testing how the server behaves in addition to how your code. So it's going to test that your code interacts properly with the server. So let's try running this test case. Let's see, I only wrote one. Only wrote the one of them. So I'm going to run that test. Okay, and I'm shocked that it passed. Oh, that's the local test. I want to run test method 1 there, the one I just showed you. Okay, so it failed. If we go look at why it failed, it says an error occurred when sending the request, unable to connect to the remote server. Okay? So, what did I do wrong? I didn't run the server. So to use this, to test your Boggle service, what you'll have to do is have 2 running Visual Studios. one to run your test cases in, and the other to run the server in. So here, let's see, I gotta make sure I'm in the right place. There's that one. This is the other one. It's actually the same solution, so both these versions are displaying the same stuff. I've got to run the service. So there I'll run the service, let that get started. And then I will put that in the background. Now I should be able to run this test. And now there's a service for it to talk to. And we hope that it passed the test. Okay. Now, suppose it didn't pass the test. Suppose it failed an assertion. How do you debug it with this setup? Where do you look for the bug? You know the bug can either be in the, it could be in the unit test. You made a mistake in the unit test, or the bug could be in the service itself. Now, normally when you're testing, you could set a breakpoint in the unit test and step through it and see where it enters the code you're testing, and then you can see where it jumps back out to the unit test, and you track down the bug by single stepping. Why won't that work here? Right. The server has no knowledge of the unit test and vice versa. They're running in completely different Visual Studios. So if we set a breakpoint in the unit test and then run the thing in debug mode, yeah, we're going to step through the unit test, but it's never going to step into the server because that's somewhere else. So you just have to decide where you want to set the breakpoint. If you think the bug is in the service, then you just need to go to where the service is running and go to the controller and set a breakpoint. Now, once the breakpoint is set in the service, I should be able to come back to the unit test and run the test. And we hit the breakpoint in the service in a different Visual Studio window. And then we can step through the service. Meanwhile, our unit test is waiting for the server to respond. So just realize that you've got two places where you might have to do debugging. And you can do it in either place, but just do it in the right window. Okay, now let's think about this scenario. Well, let's look at a couple of unit tests first. So I'm gonna let this continue. So just to show you, back here in this window, the test is still spinning, waiting for this test to happen. So if we continue the server, then the unit test is going to be happy. Unit test finishes. So let's look at another one. Okay, so this is test method 2. So it is creating a user like before. It pulls a user ID out of the response. So it calls the do method async, it calls register user. It gets the user ID. It uses the user ID to create to add an item to the test, to the database. And then it tries to add another item with a null user ID and make sure to get the right forbidden code back. And then we use an illegal item ID and same thing, and a non-existent user ID and do the same thing. So we're basically testing, we're simulating steps a client might go through. So you're going to write some tests. What's it going to take to test a Boggle service from beginning to end? You join the game, you create a user, you join the game, someone else joins the game, then you play words, and the status is coming back correctly, and then the game, time ends, and the summary comes back of all the words that were played. So that's a lot of stuff to test. What's it going to test? What are you going to have to do to make sure? Suppose you want to test that when the game ends, you get back correct list of words played. What do you have to do to test that functionality? Yeah?
I'm guessing you have to play every bit of the...
Yeah, you'll have to do everything I just said. You'll have to write the code to create the user and write the code to join the game. You have to create two users so both of them can join the game. Then once the game gets started, you'll have to fire words from both users, make sure you get right scores back, make sure the time is going down. Lots of stuff you can test, but you're basically simulating a game. Yeah?
To guarantee that you can input valid words and that it says valid and returns an accurate score, does that mean we have to manually set a board that will appear every time during that test?
Okay, right. So so here's the problem. You want to set a board and you want to test. Okay, so you got to make sure that you've got to write the unit test against an unknown board. So either you need to have some way to set the board, and there's nothing in the API that lets you use a particular board, or your tests have to be adaptable enough so that you know what the board is as the test is running. So you would have to pick words that are on the board to send to the server. Okay. And I'm trying to remember. I think there's something I do to make that easier for you, but I'll have to. I haven't finished setting up PS10 yet. So anyway, it's not an easy task to do these unit tests. And as you might imagine, it becomes. They get complicated. You could make mistakes in your unit test. How can you test your unit tests? How can you make sure your unit test makes sense? There's a way. Yeah?
Use the ARC.
We could always use the ARC. Usually that's more of in the exploration phase. How can you take your unit test and make sure that a valid service would pass the unit tests? Yeah?
Will your service still be running?
My service will still be running. You can easily run your unit tests against my service. Right? If you look at just wait a second. Look at the code that I set up here in the tester. Am I in the tester? Yeah. When I create the client, I'm just giving it the base URL. So when you're testing yours, you'll use a base URL like that, similar to that points to your service. If you want to run against my service, just change the base URL. Now, it's a little bit trickier than that because when you write your unit test, you can start your service up from scratch, and so you know there's no one in the pending game. And so you can create two users, both join the game, and you're off to the races. With my service, when you join the game, you may be the second one to join the game. So it's a little harder to control you can't restart my service, so you gotta be a little bit careful about how you do that. But to some extent, you can run your test against my service. Okay? Or maybe you just want to play it a lot. And remember, there are going to be 2 consecutive assignments where you're implementing the same API. So any unit tests that work for PS10 will work for PS11 because the interface isn't changing. It's just the database behind is different. Okay, so that's where you're headed. Yeah?
You just said we could alternatively just try playing it a lot. Does that mean we're not really being weighed the same way on our testing of these ones the same way? We can just play.
Yeah, I need to think about, I did say that, and I need to think about whether your grade will be based on your testing or just based on my tests. What would you rather have? Would you rather more of your grade depend on passing my unit tests, or more of your grade passed on the quality of your tests? What is it? Like the less code written, the better? Is that the? Yeah. I'll think about that. But the TAs tell me what happens when you don't write good unit tests. What happens when you don't write good unit tests? Besides losing points for not writing good unit tests. You have very low scores against my tests. They do this grading, and that's what they see. Missing unit tests means failing a lot of my tests because your code just wasn't adequately tested. So may not even be a trade-off here. It just may be, the grades would be the same either way. All right, so any questions about that? Implementing services, testing services? There used to be all kinds of trouble that would happen with this assignment. Just weirdness with configuring things and getting them to run in Visual Studio. And I'm optimistic that those troubles are going to go away because I'm using a different, or you will be using a different project type than we've used in the past. I think it's more robust. We'll see. I'll be prepared with the answers if you have weird trouble with the server not working right. All right, let's take a break and we'll start talking about databases. All right, let's get started again.
That last one is talking about another. Talking about the
Okay. So we're going to be spending the next few lectures talking about relational databases, because a lot of web applications and a lot of just regular applications have databases at their back end. They keep track of things on their back end. Things you wouldn't think have a database do. Your web browser contains a database system. Okay? Why would your web browser need a database system? Yeah. Say again?
Storing cookies.
Well, storing cookies, storing, what else does it keep track of? Yeah.
DNS cache.
What's that?
DNS cache.
DNS cache, history, favorites, settings, the list goes on. Lots of things that it keeps track of. Now, one thing you might do is you say, okay, I'm implementing Chrome. I'm gotta keep track of this stuff, so I'll just have files to keep track of this stuff. I have a file that contains the history, I have a file that contains this. I'll put the passwords in another file, and that's how I'll keep track of things. And that's what a lot of people do when they write a program, is they say, okay, I gotta keep track of this stuff, I gotta save it, I'll save it in a file. And when the program shuts down, I write it to a file. When a program starts up, I read it from a file. Okay? That's the wrong way to think. If you've got to write a program that's got to keep track of data over time, use a database. But why? Why use a database instead of a dedicated database system instead of just rolling your own every time? Yeah.
Wouldn't it be easy for a file to get corrupted?
Okay, he said, wouldn't it be easy for a file to get corrupted? For example, what if you have that strategy of when you're done, when someone shuts down your browser, or every time something is changed, you write it to a file? Okay, what happens when the power fails, just when your browser is writing to a file? Okay, if that happens, your file can end up being corrupted, where you can't read it again when the power comes back up, because it was only partially written. It partially changed, but hadn't been completely written. Power failed, and now your file is in an indeterminate state. Okay? Well, you could say the same thing about the database. What happens if things crash when the database is writing out? Well, the database has to be saved somewhere. It saves itself to files. Isn't it subject to the same problem? You'd guess probably not, or I wouldn't be raising this question. Okay? So the deal with a database is, yeah, if the power fails when it's writing out, it can't run without power. But it is designed, a database is designed, people have thought about this problem for decades, and it's designed so that if the power fails, when it comes back up, it recognizes the power fails, and basically it's never stuck. If a file was corrupted, it'll know the file was corrupted, and it'll go back to an older version. So from the point of view of the database, either the entire write was successful or it never happened in the first place. That's what the database is able to, the abstraction the database gives to you. Yeah?
So why can't a file do a similar
Okay. Well, he says, why can't a file do a similar thing? Because a file is not a database system. I mean, the operating system could treat files like a database and do it that way, but it doesn't. So you might say, okay, I'll use files, but I'll be smart about it, and I'll have some way of detecting if the power failed when I was in the middle of doing this. Basically, what the trick a database uses is it keeps the old state and it keeps the new state. It establishes the new state, and then it does something like writing a single bit that can only either succeed or fail, and that's when the state changes. Okay, so people have just studied this to death for decades and decades, and have figured out how to solve that problem. So why try to solve it yourself? Let the database do it for you. Okay? Maybe you roll your own solution. You create these files. You create internally. You have all kinds of, when you read from your files, you're storing it in hash tables, and you've got to get information out, and so you're writing all kinds of loops to go through your tables and find this data and go look for that data. The database guys got you beat. They have a way where you can express the data, you can describe the data you want to get out in a non-procedural way. You just say, I want a table that contains this information and that information, and it figures out an efficient way to pull it from the tables that it has. It figures out when to build indexes to make this stuff faster. Okay? If your database gets really big and you're worried about, you want to replicate it. You want to have, so folks in Asia can use a version of your database that's closer to Asia. And, put your data around the world. Put it on the cloud. Database people figured out how to do that years ago. So anything you want to do with your data, you're not going to be able to do it as well as just a database system that you can get for free. So database is the way to go. They figured out how to do backups and how to make distributed access work and so on. So databases provide you with, you often see this acronym ACID, the ACID properties: atomicity, consistency, isolation, durability. Let me just tell you briefly what they mean. Atomicity means that transaction, and so when you interact with a database, you basically say, okay, I'm beginning a transaction, now I'm making some changes, doing some queries, getting information out, now I'm done with the transaction. So a database system makes sure that every transaction either succeeds completely or fails and has no effect. So they prevent it from ever being the situation where a transaction was halfway done and then never finished. You'll never see that. Either the transaction completely finishes or it has no effect on the database at all. Yeah.
So if we have a database with just like 1 through 10 in a file with the same thing, and with the database we try to add to everyone that gets to 5 and fails, it would just be 1 through 10, but with a file, it would be like each one with the 5 would be added by 1 and the rest would be equal.
Right. So if you create a transaction that says add, you've got 10 places you want to add information, and you add the first place, the second place, the third place, the fourth place, the power fails. When it comes back up, none of those 4 things will be in the database. You never see a partial transaction. Either you see the transaction completely ran to completion, or it's as if the transaction never ran. So that's atomicity. It's all or nothing. There's no halfway doing something. There's consistency. You can define consistency properties of your data, and then the system makes it impossible for a transaction to take you to an inconsistent state. So transactions take you from a consistent state where all the constraints are observed to another consistent state. Isolation. See, another thing with your file solution, maybe that works just fine when you've got it all singly threaded, but you decide you want some more throughput. And so you make your program multi-threaded, and you have multiple threads all trying to update your files at the same time. And so you start having to put locks in, and you start screwing that up because locks are hard. Well, database has got you beat. It's very multi-threaded, and it can handle multiple requests at the same time, but to an outside observer, it looks like the transactions are happening in some sequential order. So an outside observer cannot observe any effects of parallelism. And it's very smart about how it does that, so it does it quickly. And then durability, the results of a successful transaction will not be lost. Okay? Now you have to read that with a grain of salt. If your database system is running entirely on a single computer, then if that computer is dropped in a lake, you've lost your data. But if your database system is designed to run on the cloud, you're not going to lose your data. Once you write your data, once you write your data, it's safe as long as the world doesn't blow up or something. Okay? So your data is durable. So you get all this stuff for free. Now, there are a couple of, when you talk about database systems, on the one hand, you have database systems that are designed to be embedded inside other programs. So an example of that is SQLite, which is a database system that's like inside of Firefox. So it's just a code that, it doesn't exist outside of Firefox. It's just running as a subsystem of Firefox, keeping track of stuff on the local file system. Then there are these full-blown database systems where you've got database servers, and that's the more the model we'll be using. So your data will be on a server, and your program communicates with the server much the way that your game clients communicate with servers. And that's a much bigger, fuller-blown kind of database. So you don't have to, it's not like Firefox has to communicate with a server every time you change your history. It's it's all done internally. It's just that one of the DLLs it's using is the SQLite DLL internally. Ultimately, we'll see how to take your final Boggle service with the server code and the database code and push it all up to the cloud. So it really will be running on a server. Okay, so we're going to focus on database systems in the large, where it's running on a dedicated server or maybe multiple servers around the world with multiple users with varying privileges, supporting multiple databases. Now, in reality, when you're developing, your server will be running locally, inside of Visual Studio, just much the same way that you'll be using the IIS server, which is running on your laptop. So everything will be running on your laptop, but it will be designed in such a way that you can then take that design and push it off to different servers and let it run on the cloud. So the fancy word for a database is a schema. And a schema is a collection of data for an application. So, we were talking about what instance variables, what static variables will you need to keep track of when you create your Boggle service. And you go through the same exercise when you want to design a schema to keep track of data in a database. And what you have to do for a relational database anyway is figure out what tables you need. And there's a whole science to designing tables, and we're just going to sort of float over the mathematical science behind designing good tables and just give you sort of a seat of your pants understanding. But this is an example of a table. So this is a table that contains names, dates of birth, and sort of an ID number, I guess, for the name. So that, this might be in a Hogwarts database system, keeping track of students. Okay? Now, let's think about a database for a library application. Yeah?
Oh, so you said that we have a database system,
Mm-hmm.
which that database system has multiple databases.
Yeah.
Would each one of those databases be for a specific application, or would they be like?
Yeah. So the idea is, a big commercial database system, like you go to Azure, and they got this massive database system, and you've got some small piece of it for your application. But there are other users that have their own databases running under the same framework, completely independent of you. So we'll see that when you access a database system, you pass in a password, to get at your data. All right. So let's suppose we're running a library, a public library, and we got to keep track of stuff. We got to keep track of the names of our patrons. We have to keep track of their phone numbers and their library card numbers. We've got to keep track of the titles of the books we have. We've got to keep track of the authors of the books. Each book has a serial number. We've got to keep track of that. We've got to keep track when books are checked out. So we've got to keep track of all that stuff. And you might look at this, if you were just thinking of writing a C# program or a Python program, you start thinking about hash tables and classes and all that. But we got to think about tables. Somehow we got to store all that information in one or more tables. And I told you there was sort of a science behind designing tables, but these are some of the constraints we work under. The entries of the tables, the individual entries in the table should be atomic, not compound data. In other words, we don't want to take a bunch of data and turn it into an object and store the object in one of these cells in the table. It should be, the things stored in the table should be, strings and ints and dates, not, big objects. We want to avoid storing the same information twice. And we want to avoid storing nulls, although sometimes we will. But we'd like to avoid storing nulls. So here's a bad design for some of the information. This doesn't contain all the information we need. But the idea is the first row up there says there's a person named Joe who has that phone number, card number 1, and it has Harry Potter checked out. Harry Potter's author is Rowling, and the serial number of the book is 1001. Okay? And then the next row, it says, okay, there's a book called Harry Potter. It has the author Rowling, and it has serial number 1002. So there are evidently 2 physical copies of that book in the library. One's checked out to Joe, the other's not checked out at all. Now, right away, what constraints have we violated there? Which of our design criteria have we blown off already, just for the first 2 rows? Yeah?
There's nulls.
Okay, there's nulls. It's wasteful of space to be storing these nulls. Okay, that's one thing.
And duplicates.
Duplicates. Twice we record the fact that Harry Potter's author is Rowling. Okay, it's redundant to have that information twice. Look at the 4th row. What's redundant about there? What information are we storing twice there? Yeah. Same phone number. The fact that that's Joe's phone number is stored twice. Ideally, it's just stored once. Right here, Dan has 2 phone numbers. And Dan has 2 books checked out. We end up with 4 rows because Dan with phone number this has this book checked out, but also Dan with this phone number, different phone number. It's just 1 book checked out. So you can see that's just crazy. So we can't get by with 1 table to contain the information. So let me just emphasize, we're interested in tables because that's a synonym for relation. That's the abstraction relational database gives us, tables. We put our information in tables, and we ask questions about tables. When we ask to get data out, we're given a table. All right, so bad on all kinds of levels. So let me show you a better design. Okay, so now our library has 6 tables. So the first one is called the patrons table. So what is the patrons table keeping track of? Yeah?
Names and card numbers.
Names and card numbers. So if you want to know what are the names of the patrons, it's in the table. If you've got a patron's name in mind and you want to know their ID number or vice versa, or their card number, it's right there. If you want to look up card number 4, you find out it belongs to Dan. And that's just all in one place. Then we have titles. So for every different title we have in the library, we record the title of the book, the author of the book, and the book ID. Think of this as the ISBN number. Every copy of Harry Potter is going to have the same ISBN number. Unique identifier not for the physical copy, but for all books in the world of that kind. So that just tells us all the different kinds of books we have in the library. What about this checkout table? Yeah.
So who has what book?
It shows you which books are checked out and by whom. And actually, I get a little bit ahead of myself because I didn't explain what a serial number is. So let's hold that. Let's look at phones. That's another example of the same sort of thing. Up there, it tells us the phone numbers of people. Now, yeah.
Would this be any worse if we use just name instead of card number in these right 2 tables?
Okay, why use card number instead of name over there? Yeah.
Because the name Dan is not unique,
Right, Dan may not be unique,
but we can give him a unique card number.
but card numbers are unique. So we often go for, we need some uniqueness there. Why not store the phone numbers over here in this table, in the patrons table? Because you can have multiple phone numbers, and then we'd be storing the association between the card number 4 and the name Dan twice. Dan would need 2 rows in this table, so we don't want to duplicate, so we split it into tables. So this science I was talking about, the mathematics of creating these tables, tell you when there are ways to judge when a table has redundant information. What's the catalog?
It's hooking up every book that exists in their ISBN.
Okay, so the book ID is an ISBN number. And then each book also has an internal library number, so each book has a different number stamped on it. So that's just telling you that the book that has serial number 1001, the physical book that's 1001, has an ISBN, which is 1001, which is Harry Potter. So how many copies of Harry Potter are in the library? 2. First 2 are that, and then there's 1 copy of each of the others. Then we get to the checked out table, and it tells us, okay, card number 1 has this physical book checked out. Card number 1 has that physical book checked out, and so on. So all the information we need is there, it's just distributed throughout the tables. Now, let's think what you would do with this information. Suppose you wanted to know, I want to know the names of everyone, of the name of every patron. Okay? So there's a way to ask that. So we'll see, using a query language, you would pose the query, give me the name of everyone. What would the database system have to do to answer that question? Give me the name of every patron. Yeah?
Since name isn't unique, we would have to use the card number, which is unique. And,
No. Okay, let me modify the question. I just want to know all the names that are used by patrons of the library. I don't want to make the question sound hard. Where would the database system find the answer? Yeah.
So it just pulled the column name as the
Right. So it would go find the patrons table, and it would go take all the names out of that name column and give them back to you. And it'd give you back to you in a table with 1 column with a bunch of names in it. Okay? Now, what if you ask, I want Joe's phone number? So the librarian needs to call Joe. So you ask the database system, give me Joe's phone number. Or let me change that. Yeah, sure. Yeah, Joe's phone number. Yeah.
You would need to go to your patron table, look up his card number, and look up his phone number from the phones table.
Right. So the database system would have to say, okay, it will find Joe in the column, it would find its card number 1, it will go over here to see card number 1, it will do the phone number. Now, if I ask for Dan's phone, I should be saying phone numbers, because if I ask for Dan's phone numbers, it would find Dan, card number 4, and give back the 2 numbers. So the database system is good at combining, pulling information from multiple tables, sort of, it's called a join, but joining all that information together and giving you out what you need. Yeah.
Can we ask for just an entire column, or do we need to treat these kind of like a key value? Like
No, you can ask for an entire column. One operation would be, we'll see about how to write queries later. But essentially you could say, okay, give me the contents of the name column in the patrons table. Or you could say, give me all the, well, there are no dates up here. Give me all the books that start with a letter in the first half of the alphabet, essentially. Okay? So you can by writing queries, you can direct the database system to pull out some of the rows of a table, some of the columns of a table, or to join tables together and give you information that spans them. Okay. So just like this database, to represent library information, has multiple tables, your database that you'll need to use for Boggle will need to have multiple tables. Okay? The good news is the lab next week is devoted to, I'm going to give you the design of the database that I suggest you use for your problem. And the lab next week leads you through the process of creating the database in Visual Studio. So that's an important lab to do because you'll need it the week after for your assignment. Okay, now, some of the tables are said to represent entities, and others are said to represent relationships. So those tables are entities, those tables are relationships, and you hear about things like ER diagrams, entity relationship diagrams. So what is an entity? What's the difference between an entity and a relationship? Why do I say that these tables represent entities? Yeah.
In an abstract sense, they're sort of foundational bits of information, and then you can tie them together with.
Okay, so we said they're foundational things. What's another way to put it?
Is like one meant to like reference another table, while like the other one's just supposed to like have the information like pull?
Right, so the entities are I think of them just as things. Yeah.
Well, I would say the entity or the entity
Mhm.
to the database.
Okay, so like phone numbers, names, information about books. And then relationships are relationship between entities, basically. How the entities relationship. So this matches cards to things that are checked out. So going back here, look at the names of the tables. You would say a library has patrons, phone numbers, and titles. And the library keeps track of things that are checked out and things that are in the catalog. So, it can be hard to judge what's an entity and what's a relationship. But what you'll see here is, in that relationship, look at the column name, serial num and book ID, and then card num and serial num. And in both cases, all those column names appear in one or more of these tables. Whereas, name is unique to that table, phone is unique to that table, title and author are unique to this table. So those are sort of the things. And they were using these other columns in the relationship tables to tie things together. So I don't make a big deal about this. I'm just sort of, when you read about databases, you read about entities and relationships, so it's good to have seen it before. So incidentally, we teach, and there are actually 2 different database classes that are taught here. In the first one, whose number I can't remember right now. Who knows the number of the?
It's like 5,000 level.
There's a 5,000 level database class that a large number of undergraduates take. A very popular one. We really learn about databases. We're just scratching the surface here. Then there's a graduate one if you're interested in how these things work behind the scenes. That's a much more systems-oriented look at it. Okay, so tables. I'll show you. You don't have to use my design for your Boggle service, but I'll show you my design. You're welcome to use it. Now, let me tell you some more about tables. Today we'll learn about tables. Next time we'll learn about writing queries. So there's a term called primary key. So often, not always, when you create a table, you will identify a primary key. A primary key is just a unique way to identify each row. So right here, the book ID is designed as a primary key. You would not expect to find 2 books with the same ISBN. Right? Each ISBN is unique. You might find 2 different books with the same title. That's certainly possible. They would have different ISBNs. 2 people can write 2 books with the same name. And certainly you can find author could occur more than once. Author can have more than one book. But this is by design as a primary key. So when you tell the database system that I want to have this table, you also tell it, by the way, this column is the primary key. Now, what do you think is an advantage of telling the database system that book ID is the primary key? What can the database system do with that information?
Sort.
Yeah, it can use it. So it can use, and once it knows its unique identifier, it could, for example, create an index, a hash table or a binary tree-like data structure that makes it fast to find things by book ID. And it can also enforce that constraint, and it will. So if you come along and you say, I'd like to add a new row to this table, and you give it a title and you give it an author, and you say, and I want the book ID to be 10002, it's going to say no. You can't do that. It's supposed to be unique. So it helps you keep your data consistent. So that's primary key. So the primary key over here is book ID. Now, does this thing have a primary key? We get 4 in 2 places here, and you get, all the phone numbers are unique, but does that have to be the case? 2 people can share the same phone number, the landline. Nevertheless, in a technical sense, there is a primary key. It doesn't have to be a single column. The combination of card number and phone is unique. But that's not such a useful primary key. It's more useful over here when you really have a single column that's the primary key. So that's a primary key. And you'll see in that lab, when you tell the database system about your tables, you tell it what columns it will have, what types of data goes in those columns, and then you start telling it, okay, and this is the primary key. You can also tell the database system that that's the data in some column is always going to be unique across the rows, even though it's not the primary key. And that can be useful information too. It can be enforced by the system, and it can be used to build indexes. Another thing you can do is you can set up a column where the data is generated by the system. So for example, if you want, each time you add a book, to get a new book ID assigned to it, you can tell the system, book ID is an integer, but I want you to generate it for me. And basically, every time you do an insert, instead of you inserting and saying what you want the next book ID to be, it just adds 1 to the last one, for example. So you can, sometimes it's useful to set up tables as auto increments. And finally, foreign key constraints. So those constraints we just looked at are pretty straightforward. This is a little more subtle. And the idea is here. You would never expect to find a book ID here unless what? Why would you not expect to find like 10008 right here in this column? Yeah?
Because it's not set in the titles table.
Right. It doesn't make any, you can't have a book in your catalog unless it's a book in your library. Okay? So a foreign key, you can set up a foreign key constraint that says, I would never expect to see, I do not want to see anything in this column unless it's in this column. So this is the foreign key. So we're saying this table is subject to a foreign key constraint. This will not show up unless it shows up over here. Okay? Because it doesn't make any sense. This table exists so that if we say take a serial number, we can go to the book ID and then find out what the book is. We don't want to have to go over here, get a book ID, and not find an entry in this table. Yeah?
Can something be a foreign key if it's not a primary key?
Can it be a foreign key if it's not a primary key? Yeah. Yeah, that'd be okay. So, the thing about a foreign key is the foreign key constraint can be violated in a lot of ways. A unique key, like a primary key, if you go try to insert a new key that's not unique, the problem is, right there, and the system will just say no. How can a foreign key constraint be violated? What could you do to either of these tables to cause a foreign key constraint to be violated? To cause, what could result in something being here, but not over here? Because right now we're okay. What could we change about a table? Yeah?
You could delete an entry.
Right? What would happen if I deleted this row from this table? Innocently deleting a book from the table. How does that violate a foreign key constraint? This is now orphaned. Okay? What else can I do to this table that would screw up, that would violate a foreign key constraint? Yeah?
Change book ID.
Yeah. What if I said to the system, I don't like 10005, change this to 10008? Okay, suddenly there's a violation. So I changed the data over here, that caused the problem over here. Now, what could I change about this table that would violate a foreign key constraint? Yeah?
Same thing that you just said, change the book ID.
Okay? I could try to change a book ID. That's another thing I could do. One more operation I could do. Yeah?
You can add something to it.
What if I added a new row that contained an unknown book ID? So the database system, when you set up a foreign key constraint, it lets you tell it how to resolve the problem when it happens. So let me show you the options. So let's see what I've done there. Okay. So that is, I'm changing that to 1008. Okay? So that's an example violation. And what the system will do is you can tell it if a change to either table would violate a foreign key constraint, don't allow it. throw an exception or whatever. The second thing you can do is cascade the change. And the third thing you can do is use nulls to clear things up. So let me just give you some examples. So let's let a delete cascade. Suppose I delete this row from this table. What do you suppose it means to let that delete cascade to avoid the problem? Right. If you delete this row, then you delete every row over here that references 10003. So deleting this row will also delete that row. Because after all, if the book is no longer in your library, it doesn't need to be in your catalog either. So that's how a delete would cascade. Okay, let's let an update cascade. Suppose we change the ID number to 10008. What's it mean to let that cascade? Then it's going to, we just change it over there as well. So you can choose. Do you want it to be forbidden? Do you want it to cascade? Another option is nulling after a delete. Suppose you change this table, you change that, you delete that. So what's the null option? What do you suppose that means to do? It means you just store null as the book ID. And I don't really like that option, but it's a possibility, because now when you go look over here, you've got this special case where you've sort of got these orphan entries. Yeah?
Can you choose how to handle these based on what you're calling, like add, delete? Because if,
Yeah.
let's say if I want to delete something, I want to delete over there, but if I change something over here, I want to change it over here.
Yeah, so you typically these options apply to changes you make to this table that violate a constraint over there. And you can do a different thing on delete than on update. Okay, so that's nulling after a delete. Here's nulling after an update. We change this to 1008, it changes to null over there. So you can mix and match. Okay, so that brings us, this is where we'll pick up next time. We'll actually see how to write queries, pull information out of the database.